Today's topic is data link protocols. We have the number of protocols are there in the data link layer. Now we are discussing the two protocols. The first one is HDLC and the second one is PPP. Let's start with the first one. That is HDLC, and HDLC stands for High Level Data Link Control. The HDLC is a group of communication protocols of the data link layer for transmitting data between the network points or nodes. So what it means, basically HDLC is a communicating protocol. Whenever we want to communicate with each other, or whenever we send the data, or the data is transmitted from one system to the other system, a protocol who is responsible for this transmission is known as HDLC. Since it is a data link protocol, data is organized into the frames. Now in this case, the data is available in the form of frames. A frame is transmitted via the network to the destination that verifies its successful arrival. Now the frame is transmitted from one system to the other system, from the source to the destination, that verifies that the successful arrival of the data is reached at the receiver side. It is a bit oriented protocol that is applicable for both point to point and multi-point communications. Bit oriented, what it means, the data should be sent in the form of bits. We all know we sends the data and the data is traveled in the form of bits. We can combine the bits and make a frame so that we transmitted our messages in the form of bits. But the frame is the combination of bits. That's why it is a bit oriented protocol, and it is suitable for both the communication. The first one is point to point communication and second one is multi-point communication. Okay, this is all about the HDLC protocol. Now the next is the transfer mode. Transfer mode means whenever we want to transfer the data from one system to the other system, we have the number of modes. In which mode we are sending our data. So the HDLC supports the two types of transfer modes. The first one is normal response mode and the second one is asynchronous balanced mode. So what it means, in the case of HDLC, we have the two transmission modes are there. And these modes are known as, the first one is normal response mode and the second one is asynchronous balanced mode. Now let's start with the first mode, that is NRM, or you can say the normal response mode. Here two types of stations are there, a primary station that sends commands and the secondary station that can respond to the received commands. It is used for both point to point and multi-point communication. Now let's start discussing the first mode. The first mode is the normal response mode, and this mode is basically primarily used for the stations who sends the data and the secondary station who receives the data. And this mode is applicable for both the communications for point to point and for multi-point also. So look at the diagram, the normal response mode. In normal response mode, it is a primary station, or you can say sender is known as the primary station and it is a secondary station. Secondary station means the second station, or you can say the receiver, it acts as a secondary station. Now it can send the commands or queries or questions, anything you want to say. It sends the commands and commands can be received by the secondary station and it sends the response regarding to these commands. This is the functioning of the normal response mode, and this form is known as point to point communication. So point to point communication means single to single node communication. Whenever there are one sender and one receiver is there, so in this case you can say it is a point to point communication or node to node communication. Clear? And the second one is multi-point communication. So what will happen in the multi-point? As the name implies, multi-point, multi means more than one. Now we have more than one secondary stations are there. Primary station remains the same, or you can say The primary station is also known as the sender, who is at the sender side. It is a primary station who sends the commands, but at the receiver side, we have a multiple stations are there. And these multiple stations are known as the secondary stations who responds. And we have the multiple stations. So whenever a command is received at the receiver side, a multiple stations who can give the response at the same time. That's why its name is multi-point communication. This is all about the normal response mode. Now we have the next, the asynchronous balanced mode, or you can say the ABM. Here, the configuration is balanced. That is, each station can both send commands and respond to the commands. It is used for only point-to-point communication. Now, two things that has to be remembered in the case of asynchronous. The first thing is, in this case, both the station, they can send the commands as well as they can receive the commands. And second thing is, asynchronous balanced mode only used in the case of point to point communication as shown in the diagram. And we all know what is the meaning of point to point communication. Means node to node communication. In this case, we have a single user at the sender side, and also we have a single user at the receiver side. So it is called a station. Also, it is also called a station. Now, look at here at the diagram as shown, command slash response, because it can send the command automatically. It can also receive the command. Whenever it receives the command, so it can respond to these commands. So both the stations in this case, they can send the commands as well as they can give the response back to the commands. The next is HDLC frame. Frame means we also know we send the data in the form of the frames, and frame has a particular frame format is there. Whenever we are using the HDLC protocol, it also has a frame format is there. So HDLC is a bit oriented protocol where each frame contains up to the 6 fields. The structure varies according to the type of the frame. Now, it is a bit-oriented protocol, and in the case of HDLC frame protocol, it has contains up to the 6 fields, 6 different fields, and the structure of the frame, it varies according to the type of the frame, that which type of the frame now we are using. The common frame format for the HDLC as shown in your diagrams. Now look at here. The first part is flag. Flag is of 1 byte, and flag means the special pattern. Like here, it starts from 0, then 6 times 1, then end with 0. Basically, it shows the starting of your frame. Now the next is the address. It is also contain the 1 byte. The third one is the control. It is also contain the 1 byte. Next one is the payload. Payload means the data which holds the data, the actual data that we want to send. And the size of this payload is variable. Variable means it varies from data to data. How much data it can contain depends upon that data, its size is varying. Now the next is FCS, that is from 2 to 2 or 4 bytes. Now at the end, the flag is there, and the flag is also contains the 1 byte, and it has a special pattern, starts from 0, then 6 times 1, then end with the 0. So this is the frame format. Now we are discussing all the 6 fields. Let's start with the first. It is a flag. It is an 8-bit sequence that marks the beginning and the end of the frame. The bit pattern of the frame is 0, then 6 times 1, then 0. Now the second one is the address. It contains the address of the receiver from where we are sending the data, the receiver's address. If the frame is sent by the primary station, it contains the address of the secondary station. Who is the primary station? A sender is a primary station. Who is a secondary station? A receiver. So this particular field can contain the address of the receiver. If it is sent by the secondary station, it contains the address of the primary station. Suppose in the case of response, whenever a response is sent from the secondary station to the primary station, in that case, it holds the address of the primary station. Or you can say the sender's receiver's address. The address field may be from 1 byte to the several bytes. Now the third one is the control field. It is one or the two bytes containing the flow and the error control information. Basically, control field, the size of this field is either 1 or the 2 bytes, and it controls the flow and the error control of your data. The next one is the payload. The payload, this carries the data from the network layer. Its length may be vary from one network to the another network. So what it means, it contains the data from the network layer, or you can simply say it holds the data, the actual data that is traveled from one node to the other node. Now the next is FCS. It is a 2 byte or the 4 byte frame check sequence. FCS stands for frame check sequence for error detection, or you can say FCS is used for the error detection. The standard code used in the C is CRC. The standard method that is used in the case of FCS for the error detection is known as CRC, and CRC is cyclic redundancy check. This is all about the frame format of the HDLC. So the next is the types of HDLC frames. Now we have the different types of frames are available. So let's discussing these different types of the HDLC frame. There are three types of HDLC frames. The type of the frame is determined by the control field of the frame. Now we have the three different types of the frame, and which type of frame is this? It can be detected by the control field. We have a control field in the frame format of HDLC. So we have the three different types of the frame, and these frames are the first one is the I frame, then the S frame, then the U frame. So let's start with the first frame, that is I frame. I frame or the information frame carry users data from the network layer. It carries the users data. They are include flow and the error control information that is piggybacked on the user's data. Basically, it can also include the flow and the error control information, in which flow the data is traveling from sender to receiver and how we can control the error. This information is also added in this particular frame. The first bit of the control field of iframe is 0. In the case of iframe, the first bit of the control field is 0. Whenever a control field is 0, so we come to know that this frame is a iframe. Now the second is S frame. S frame or supervisory frame do not contain information field. No information is there. They are used for flow and the error control when piggybacking is not required. They are basically used for to check the flow control methods and the error control methods. The first two bits of the control field of S frame is 1 0. Whenever the first two fields of the HDLC frame is 1 0, then we simply know it is a S frame, or you can say the supervisory frame. And the last one is U frame. A U frame or unnumbered frames are used for myriad miscellaneous functions. Like miscellaneous function means the rest of the functions that are not defined, like the link management, how the link is maintained between the user and the receiver, between the sender and the receiver. It may contains an information field if required. If there is a requirement of this, then it also contains the information field, and information field contains the information about the particular frame. The first two bits of the control field of U frame is 1 1. Whenever a control field value is 1 1, we simply know it is a U frame. So what it means, as it defined in the starting, that we can detect the these frames by the control field. Suppose you received a frame, you simply check the control field. If the value of the first bit of the control field is 0, then it is I frame. If the value in the control field is 1 0, then it is S frame. If the value in the control field is 1 1, then it is a U frame. So these are the three different types of the frames, or you can say the three different types of HDLC frames. So have as we discussed in the previous slide, we have the three different types of frames, like I frame, S frame, and U frame. I is the information frame, S is the supervisory frame, and U is the unnumbered frame. So these are the different segments that holds into the cases of these frames. The frame format is there. In the case of iframe, first we have a flag. One thing that you have to remember, every frame, it starts from a flag, it ends at a flag. Second is the address, then control, then user data, then FCS frequency check sequence, then flag. In the case of S, it starts from flag, it ends at flag. Only it contains the address, control, and FCS. Address means the receiver's address, control information is there, then error detection is there. No user data is in the case of supervisory frame. Then the third is unnumbered. It starts from flag, it ends on flag. Second is address, the address of the receiver, then control, which contains the control information, then management information, because U frame, it performs the miscellaneous functions like management link, and then the FCS for the error detection, and at the end the flag is there. So these are the different frame formats of the three different frames, the I frame, S frame, and U frame. And one thing that you have to remember, every frame starts from the flag and ends on a flag. So this is all about the HDLC frame. Now we have a second protocol over there, that is PPP. It stands for point-to-point protocol. Point-to-point protocol is a communication protocol of data link layer that is used to transmit multi-protocol data between two directly connected computers. Now the second protocol is point-to-point protocol. It is also communicating protocol like HDLC, but the difference is there. This protocol transmit multi-protocol data between the two systems who are directly connected. So what it means, that's why its name is point to point. Whenever there are two systems which have a dedicated connection or they are directly connected to each other, then we can say here we have a point to point connection over these systems or computers. It is a byte oriented protocol that is widely used in broadband communications, having heavy loads and high speeds. It is a byte oriented protocol, and normally it can be used in the broadband communication. Whenever we have a heavy load and whenever we require a high speed of data, then we go for point to point protocol. Since it is a data link protocol, data link layer protocol, data is transmitted in the case of frames. So all we know, it is a data link layer protocol. So the data that can be traveled from the sender to receiver, they traveled in the form of frames. So this is all about the point to point protocol. Now also we have a point to point protocol frame. Now look at here. It starts from a flag, then address, then control, then the protocol is there. Then we have the payload, then FCS for error detection, then ends at the flag. Same with the HDLC, it starts from flag, it ends on flag. Now we discuss a PPP frame format. Point to point is a byte oriented protocol where each field of the frame is composed of one or more bytes. The field of the PPP frames are, the first is the flag. It is a 1 byte that marks the beginning and the end of the frame, and it has a special bit pattern, and the bit pattern is 0, 6 times 1, then 0. In this case, the flag is there. Now the address, it is a 1 byte field which is set to all the 8 bits are 1 in the case of broadcast, and we know we use the point to point protocol in the case of broadcasting, and the address set to the 1111111. Then we have a control field, which contains the control information, but the value of the control field is, the first two bits are the 1 1, then rest of the 6 are 0 0 0 0 0 0. Then we have a protocol. It is 1 or 2 bytes that define the type of data contained in the payload field. It denotes what type of data that is contained by the payload field, and we all know payload holds the actual data. Now the next one is payload. This carries the data from the network layer. The maximum length of the payload field is 1500 bytes. The maximum value is 1500. but depends upon the type of the frame. Either its value is 10 bytes, 20 bytes, 30, 40, 100, 500. But what is the maximum value? 1500 bytes. However, this may be negotiated between the endpoints of communication, but they can be depends or negotiated by the endpoint communication. And what do you mean by the endpoint? Where the communication can be occur. Endpoint means sender and receiver. And the last one is FCS, frame check sequence. Basically, it is the value of this frame is either from 2 byte or the 4 bytes. And the frame check sequence we all know for the error detection. And the basic code that is used in the error detection is CRC, that is cyclic redundancy check. So this is the frame format and the description of the fields that contains by the point-to-point frame format.